So again, this is an older problem as far as when it was written. It's talking about surveying when students really had a big deal about choosing Coke over Pepsi, but we said we had 500 total students. And of the 500 total students, 341 students liked Coke, 364 liked Pepsi, and 270 of them liked both. So we wanted to know how many students did not like either one of them. So we have to do some eliminating here. First off, let's figure out the total number of students that liked Coke and or Pepsi. And when we do that arithmetic, we get 705. Now, of those 705 students, we're going to eliminate the ones from that like both. So subtract 270 since they liked both, and we end up with 435 students there. So 435 students liked Coke and or Pepsi at this point. So from that, if we want to know how many did not like either one of them, we take this 435 and subtract it from 500, and we see that 65 students liked neither one of those two. Next question. A mother tells her 3 sons that when they get home from school, they can have some sugar babies on the counter for a snack. Each boy comes home by himself and believes that he is the first one to arrive. Therefore, he takes what he believes is his fair share and goes off to play. The mom gets home and sees that there are 16 sugar babies remaining on the counter. How many sugar babies were there to begin with? Well, we're going to do a little bit of working backwards. We know what we ended up with. We ended up with 16. So we multiply that by 3/2. Because if we start off at the beginning, each child is leaving behind 2/3. So essentially we're taking 16 and dividing it by 2/3, which is the same thing as multiplying by 3/2. And we take that and multiply it by 3/2 for the second child, and we do that by 3/2 for the third child. The 2 and 2 is 8, 16 is 2. We have 3, 9 is 27, 27 and 2 is 54. So the mother started off with 54 sugar babies. All right, the next question dealt with drawing triangles inside of a triangle. I did have a student who got this one right, or a pairing of students. So we're here with it, and it says we want to divide the triangle below into 7 triangles so that the same number of sides meet at each vertex of the new figure, including each of the 3 vertices of the original triangle. So the first triangle I'm going to draw is going to look something like this. And I'm going to draw one of those from each one of my corners. All right, so that's 1, 2, 3 triangles there. Now this inner blob I'm going to turn into triangles as well. So when I come here, I now construct a triangle here. So now I have 1, 2, 3, 4, 5, 6, 7. So that's how I construct my 7 triangles. Next problem, I have a circle. Now this is one from geometry, so this is one you can thank Ms. Keith for. This side is 9, this is 8, and this is 10, and we want to know what the length of this value is right here. Well, in order to solve that out, it's the ratio of the outer part times the inner times the entire part equals to the ratio of the outer part times the entire part. So the outer is 8. I'm sorry, I'm saying ratio, it should be the product. So I've got 8 for this length and 18 for this length. This length is 9, and this whole length here is 9 plus x. Now, at this point right here, I'm going to do some simplifying on both sides. So this is going to be 2. So I get 16 equals 9 plus x. So 16 take away 9 is 7, so 7 equals x. So this portion right here would have been x. Again, that's a problem that will appear periodically on ACT and PSAT type questions. Next problem, problem number 11. It says 7 people meet for the first time and each shakes each other's hand. How many handshakes take place total? Well, you've got 7 people, and they're each going to shake each other's hand. So 7 times 6 would be 42. Now, we're going to take that 42 and realize that if person A shakes person B's hand, that's the same as person B shaking person A's hand. So the total of 42 handshakes, we divide by 2, and we get 21. So there are 21 total handshakes that go on from there. Next question was the question about you roll 4 standard 6-sided die, and the product of the upper faces is 144. So which of the following could not be the sum of the values? Well, thinking about what this would be, I'm going to take 144 and I'm just going to factor it. That's 12 and 12, and that's 4 and 3. 4 and 3. Now, there are several different ways to factor this out, but this is the one I'm going to do first. So if I take 4 plus 3 and 4 plus 3, that's 14. All right. My 12 and 12 could also factor into 6 times 2 and 6 times 2, in which case that's 8 and 8, which would be 16. All right, another possibility here would be 6 times 2 mixed with 4 times 3. Well, 6 and 2 is going to be 8. 4 and 3 is 7. 8 plus 7 is 15. And then I did not write the possible way. There is a way to get 17. Let me think if I can remember how to do it. It's not coming to me. There is a way. The correct answer here was 18. I wished I'd written down the way to get 17 out of it. Let's see. Wait, 6 and 2 and what about? All right, hold up. 6 times 4 times 6 times 1. So 6 and 4 is 10. See, 6 and 6 is 36. 36 and 4 is 144. So 6 plus 4 is 10. 10 plus 7 is 17. So the only one that you could not get there was 18.